You know that basically this sort of conference, the sort of overall theme seems to be more of end user. And then of course the other side of the value chain is the primary production. So I'd just like a show of hands in the audience. Where would you classify yourself, as an end user or primary produce? So it's almost 60-40 or something like that. I must admit, Jansi, if we had this in Gauteng, there would be 1,000 people here, and there would be like 50-50. But if you had this in Rustenburg, it would be almost all primary produce, or Polokwane, Tabazimbi, and so on. So, if you are a major sort of, in the end user sort of part of the value chain, then there could well be a little bit of a gap in your sort of primary produce side in order for you to become more balanced. I think maybe this is where Jansi put together this group of both sides of the end member, the value chain. And you can see here in the first slide is basically both ends of the value chain, namely right in the middle is the primary produce, the platinum group minerals, and of course a variety of applications sort of surrounding it. The sort of, I was prescribed, look, please talk about this, and this, and the chances are I may talk about one or two of them. I'll get muddled towards the end and I'll run out of time, and I'll probably get to something like 3 out of 7 or something like that. But the chances are that this PowerPoint presentation will be available, and of course you'll be able to fill in all the gaps. Talking about an oversupply of resources, this talk is probably one of those, and I can only just cherry pick a few of the slides and actually have time to talk about. So certainly there'll be a lot of value added sort of post-talk, I think. So anyway, I'm going to sort of go through fundamentals, and the reason why I talk about fundamentals is because I'm a university professor and I teach a whole spectrum of students that may be at one end of the value chain and finish up at the other end of the value chain. So they need to know the fundamentals in order for them to understand either to find it, to mine it, to process it, and of course also to look at end uses. So bear with me, there's a few sort of fundamental slides about the origin and distribution of the platinum group and why it's different from gold and why it's endangered. Those of you who go down to the fresco on the first floor, the artists have got a very nice Big Five depiction of our commodities where they've used elephants, the 5 elements, and I think the biggest one is probably gold or something like that. And the most endangered, I think, is for them is platinum. Okay, so that's a very nice analogy. Okay, well, I talk about platinum group elements, and I also talk about platinum group minerals. I hardly ever talk about platinum group metals. End user tend to be PGM metals. Primary produce, I understand the origin and distribution of the elements, and we know that elements form minerals and minerals form rocks, and we know the mining is all about getting the rocks, taking out the minerals, taking out the elements, and you finish up with metals. It's amazing how a lot of end users actually have no concept of what that is. They think that these commodities come in bottles, and so if you want 1 gram of platinum and 1 gram of iridium, you just go to the shop and you buy the bottles. Well, sorry, this is part of our sort of educational outreach, not only to our own sort of students or members of the population, but also the world. So I'm going to talk about PGEs rather than PGMs all the time, but I may ultimately sort of drop a few M's and E's and so on. But probably the most important thing is that the PGEs are precious, and of course there's a variety of end uses which are implied by precious, like bullion and ETFs. Some of you may be into the cryptocurrency environment. There's a big change in the demand for platinum, for example, in that. They're noble. Some of them you may understand noble. They're also heavy. Sometimes the connotation of heavy metal pollution, blah, blah, blah. Well, siderophile, chalcophile is more fundamental, but knowledge of what these mean has a profound effect on understanding the distribution of platinum group elements in the Earth's crusts, but also a lot of the applications, whether it be fuel cells, whether it be metal coatings, whether it be the medical or automotive, whatever, are based on those fundamental sort of siderophile and chalcophile properties. Okay, the reason why we talk about a platinum group, of course, is that they're all sort of related on the periodic table, very close together in terms of vertical columns and horizontal rows. But you note that there are two transition rows. There's so-called light PGEs and there's also heavy PGEs. But they don't come, like gold, as native metals. They're always in compounds, mainly sulfur. And if you see where sulfur is on the periodic table, you will see that you have sulfur elements such as selenium and tellurium. And then right next door you have the semi-metals, which are things like sort of arsenic, antimony, bismuth, and so on. Those are critical for natural distribution and natural distribution controls. So we sort of answer the question, where do we find platinum? Why is it so enriched in South Africa? A lot of these sort of associated elements as a key. Also, if you look at the little red box there, you'll see just above it, there's a whole pile of elements, iron, cobalt, nickel, copper. So they tend to be associated. And as Paul was saying, you tend not to get like an iridium. Now, don't get me started on the iridium anomaly. That's, hopefully no one will go and try and mine the KT boundary because it's that thin, but it's worldwide. You're not going to sort of do that. And there's an interesting story about why it's called the iridium layer, because it's just one of the PGEs. Anyway, carrying on, I'm just going to go through the fundamentals. Some of you may need almost like a relief from your everyday high-stress environments. Let's go back to the beginning and say we generated nuclei, atoms, minerals 1.0. Okay, and this is using the speak that my son, who's an IT specialist, and rocks 1.0, and that's basically out there in the cosmos. I'm sure a lot of you watched Carl Sagan when you were younger, and certainly Neil deGrasse Tyson when you're a little bit older in the new generation. And then we generated our planet Earth, and so rocks 1.0 turned into magmas 1.0, which then crystallized minerals 2.0, created rocks 2.0, and of course 2.1 and 2.2 rocks is the core and the mantle of our planet. To cut a long story short, most of our PGEs went into the core. So how do we mine the core? Well, if you watched a few sci-fi movies, Star Trek and so on, maybe we could, but you know that there's technology out there and let's say interest through NASA and others, the European Space Agency, that they want to mine ancient cores, i.e. iron meteorites, asteroids, comets, and so on. Maybe in the next millennia, we may well be sort of giving up on the bushveld and mining, just gathering meteorites, iron meteorites. Hopefully the Hoba will stay in its pit in northern Namibia, and the Gibeon meteorites on display in the museums around the world will also stay there. But it could be a resource. No, I'm only joking. Anyway, once we actually generated the planet, you can see in the bottom there, basically rocks 2.2 generated magmas 2.0, minerals 3.0, and rocks 3.0. And rocks 3.0 is what we mine in the crust. So we have a lot of rocks 3.0 up in the bushveld complex. This is just really a graphic. Again, you can probably look at this at your leisure when you look at the YouTube video. It's just really showing you the cosmochemical sort of aspects of the PGEs and their fate in terms of forming the condensates, the early planets, and then all disappearing out of our sight in the core. You will realize that it needed a supernova to actually generate the platinum group elements because they're not made in stars. It's only when they blow up. And so all those spectacular photographs of the Hubble Space Telescope is showing you where it came from. This is a sort of detail of that cosmic abundance, and I'll draw your attention to the blow up there, where I've shown you that, in contrast to what we see in the platinum mines, all the 6 PGEs are quasi-equal in abundance. So they started off more or less the same, but we then lost a significant amount, certainly of the higher temperature, the more refractory, the iridiums, the osmiums, and the rhodiums, into our core. So we were left with the platinums and palladium. So when the people say, look, we just buy platinum group elements in bottles, but you know that for every ton of ore produced, you basically get dominant platinum, plus minus palladium, and then practically nothing else. So if you actually have, when I draw the analogy with the heavy and light rare earths, which we'll talk about probably later, basically it's the heavies that are very important, and maybe the heavies are also very important in the platinum group as well. Again, I'm saying we lost most of our ore deposits in the core, and of course there was this tremendous fractional differentiation of the platinum group element in our planet to the core, and of course the fundamental controls of that migration helps us in pyrometallurgy, helps us in end user understanding of the phenomena. So the summary, the fundamentals, we generated all these elements, and then of course the siderophiles, the iron-rich loving PGEs finished up in the core. And that's why, for example, if you look at the abundances, this is a graph showing you the percentages of each of the platinum group elements in ores compared to the primordial planetary homogeneous planet. So you can see the quasi-equal nature has been strongly sort of affected by this formation of the core. Okay, so I'm going to go through sort of platinum applications very quickly, but I actually tend to repeat myself because some people actually tune into certain ways of the depiction of, this is a pie chart. Some of you may be pie chart people, others are bar graph people, others are sort of pictures of jewelry draped around people's bodies and things like that. But certainly you can see here, automotive and jewelry. Jewelry is a good one. I mean, that's a lot of potential. And some, maybe we can go to the next one. This is like last year and this year. It's a pie chart, and obviously you can see the two, which are the big segments. But you'll see something which is called investment at the top. 0% last year. This year, 10%. The biggest growth in demand is in investments. Bullion, sort of underpinning currencies, whether they be real or crypto, using platinum as your sort of your support. And of course, as you know, cryptocurrencies could be the future in money. Part of the fourth industrial revolution is to get rid of money, and maybe you can go to the, like for example, the Mercado market and buy your oranges from Zanin with cryptocurrency, which you've earned because you've been working at a platinum mine in the Limpopo. Again, people like to see the applications driving this home: automotive, industrial, jewelry, investment. Look at that number, from 2% and 11%. I mean, it's literally in a couple of quarters of a year where you've actually had this incredible. Is this a burning match, or is a gradually heating up hot iron? Who knows? This is where we should be in this innovation conference. Again, this is sort of, again, repeating the point. I'm not going to spend too much time, but obviously the detail of all of this, if you do indeed want to know what are the details of all the individual applications and end users, it's all encapsulated in there. And as Paul was saying, automotive is a big sort of question mark there. Jewelry is an interesting one because, as you know, we tend to provide most of the PGEs, and they come back as jewelry. And there's been a variety of sort of trying to localize and indigenize more parts of the value chain, in a sense of perhaps using some of the platinum, palladium, rhodium and creating their own jewelry. There's a few startups in Cape Town. I got involved and I was sort of doing quality control where they gave me their alloys and I analyzed it for the platinum, palladium, rhodium to make sure their specifications were within tolerance. Investment, this is the interesting one, and I'm out of my depth here because I'm not an investment banker, but hopefully somebody who knows somebody who knows somebody will understand what's going on here, and I'm just sort of underlining this. For example, in the World Platinum Investment Council, is it possible or likely to have cryptocurrency backed by platinum? Who's sort of waking up when they see this? Who are people who are into the financial side of things? Anybody here? You should be. You should be. I think, to cut a long story short, we are the major suppliers of PGEs. The world is watching us. You think of Prof du Plessis and you think of Cielo Colisi. They've got weight on their shoulders. We all have weight on our shoulders because we are the future of those commodities. 95% of the future world resources is in South Africa. It's a pretty sobering thought. 95% of the population of South Africa is making sure Sia actually starts their first game against the All Blacks. Okay, no pressure. But not only is there a variety of applications in terms of use of the commodities, but it's everywhere. I mean, this is effectively a whole lot of countries. But the interesting thing about it, while Europe is a major sort of draw card for platinum, look at how there are countries taking all the palladium as well. So palladium is actually starting to replace, but certainly to augment. And the nice thing about it is that you get effectively the platinum and palladium prices pretty close to the same. And so you're getting a bit more for your product. And the interesting thing about this, on the left-hand side, is the effect of recycling. If you look at those blue bars, it means that year on year, you're actually doubling, tripling, quadrupling the amount of platinum that is actually produced. And to my naive mind, is that if you have more and more platinum out there, surely you can recycle more. But interestingly, you see, it's not necessarily a constant percentage of the total platinum in circulation. It's actually a constant percentage of the annual product. So there's obviously other powers that sort of controlling. It's almost that they're trying to constrain the amount of recycling. I think these are numbers that you can't read, but you know, is the supply and demand sort of matched? Is demand more than supply? Well, over the years it's sort of fluctuated backwards and forwards. Right now I think we're almost completely sort of equal supply, but this investment with this extra 10% from naught in 1 year could well be a sort of the future where not necessarily the demand increases, but the sort of the pieces of the pie chart may change. And so a number of these tables are more or less saying that right now it's sort of looking good. Demand, prices, really for us, as you know, it's all about production costs. There's no will, there's no sort of confidence. People are just sort of scrambling around and in sort of opposite directions. Probably we've got to try and sort of sort out the production costs. Okay, again, I'm just sort of beating the drum about this. Some of the text is actually interesting with regards to this EFT requirement or this bullion. Another thing where basically you look for the fine detail about is it positive or negative in terms of supply and demand. But the interesting things is about the demand. Obviously this particular diagram is talking about the bitcoins and things like that. Also the supply, there's issues with regards to production. I think, I'm not sure if it's this one or the next one, where we're talking about, no, all right, I'll just bypass that. This is something which came to me because I invest with Alan Gray. And as a geology professor, I mean, I say, look, is any of my investments actually in resources? And they look at me and they say, you must be joking. And then I get this sort of thing in the mail. Do you enjoy pain? What about the platinum industry? Part of the problem. Could we be part of the solution? The pain is in the productivity, i.e. we can't sort of drop our costs. It's costing too much. So basically, where do we get this stuff from? It's basically Southern Africa. As you know, Zim is a sort of a fairly sort of bit of a wild card with regards its future. You don't have any electricity to make these platinum mines work. And then Russia and North America, they're major suppliers of palladium and not platinum. And they're only a small percent, certainly North America. And here's your bar chart to show that. South Africa is sort of way out in front. Okay. Where are we going? Obviously, it's all in one part of South Africa. Should they secede, then northern South Africa becomes its own sort of place, like southern Sudan. There's mines everywhere. I'm not going to sort of go through that. Reef-based mining deposits, sort of planar rather than pipe or disseminated. So in that respect, It's a relatively simple situation, although underneath there's quite a lot of problems. There is, of course, variations in the grade within the reef, and so if you make sure you get the whole reef and not just part of it. As I mentioned, platinum, palladium rich, and all the other ones are much, much, much less. There's another aspect about this, is that when you actually look at the sort of ore-bearing horizon, which could be only a few centimeters, it may run over 60, and in terms of total, 100 grams per ton. That's a lot in the platinum industry. But because it's narrow, but you need to mine 1 or 2 meters, the dilution is quite horrendous. So you finish up with very economic grades, but only an average of about 8 grams per ton, or 5 grams per ton. Even though that the actual original horizon, very narrow. Maybe with innovation and for IR, we can have robots sort of picking out the 10 centimeters of the reef underground, 3 kilometers underground, and bringing it back without all the waste rock. Who knows? Again, these are flow sheets, how mining, you take the rock out and you crush it and you separate the minerals and then you separate the elements and so on and so on. And that's what these tables are more or less covering. This is an interesting one. This is a bar chart showing you the operating costs of all the platinum mines. So along the x-axis, along the horizontal axis, are all the mines. And then on the vertical axis is effectively rands per ounce. And it's twofold in the sense of what the operating costs are, and then there's a horizontal line which is a break even for those mines. There's only a few on the left hand side there. Look at Magalakwena, a huge mine in terms of tonnage, and the operating costs are very low. And you can see a lot of the traditional platinum mines are operating in sort of bad territory in terms of operating costs. So how much time have I got left? Is it 5 minutes? 1 minute? Okay. 5 minutes? Well, look, I mean, I have lots of pictures of people sort of enjoying themselves in this sort of 40-degree centigrade, 100% humidity mines. But I'll basically do this a quick visual. I mean, the reef is actually quite extraordinary underground. Some of you probably will never want to go underground. And some of these students I've taken underground and said, now I know what I don't want to do, Prof, is to work in the mines. But, you know, we have this incredible responsibility of actually getting the stuff out. And I just want to show you a video. Maybe if I can get this to work. Is it working? This is a rock of ore where we digitally removed, and that sort of spinning galaxy is all the platinum group minerals. So we've done mineral separation in cyberspace, and it basically comes back to what Paul was saying about the research efforts. They're using the tools in order to better understand and also to better produce recoveries and so on. There is so many mineral parageneses within the ores. We need a lot of smart mineralogy in order to make sure that the recoveries are sort of up there plus 90%, because quite often the make or break of the mining industry sometimes is the processing to get it out of the rock. And there's lots of funny things. All the bright stuff in these pictures is the platinum, and they're all sort of tiny things with ginormous crystals of gangue. To get the ore from the gangue is a major, and Chimera and other sort of research programs, minerals to metals and so on, which is a THRIP thing, is all about trying to improve recovery. Sorry, running out of space. Exploration, again, I'm not going to spend too much time, that's basically Paul's, but basically PGEs concentrate inside magma chambers. It's all hot. One of my former students, John Bristow, said, yep, there's a lot of ore deposits to come. We think that the area around the bushveld was quite anomalous with regards to acidophile elements because of the early earth history. There's new deposits coming up, as Paul has indicated, in the northern limb. What does it look like? There's Judith looking at the Marinsky Reef about 26 years ago. This is the sorry part of the platinum industry. This is Atok or Bokoni or Leboa. It's now closed, but it's one of the best places to take the new generation. Said this is what the Marinsky looks like on the surface. In the western bushveld, there's no outcrop whatsoever, even though it's a huge platinum industry. it was just covered with black soil. So there's a lot of potential exploration targets, but there's also lots of various interesting approaches to finding it. Because of the databases being so big, and with the artificial intelligence, a lot of sort of machine learning and sort of big picture, small picture, micro picture type of processing could occur. So there's a lot of scope for stakeholders and people within this industry to sort of keep the exploration effort up, and also to use big data. We have a whole variety of sort of fundamental aspects about when, how, why, where, and that's what all these sort of words are. I'm not going to go through that very much, but here's my final sort of take-home slides. It's all in an abstract, so it's in text form and it's in slide form. And I'm just going to cherry pick one or two of these lines. You know, basically 95% of the known world reserves are located in South Africa. Let's go to this one. What else do I need to say here? It's hard to mine the PGEs. It's very expensive. So it's a capital, energy and labor intensive industry. Unlike gold, where you can just go and stub your foot over a piece of gold. It has to be processed. You can't do it with a one-man show and a wheelbarrow. It requires millions and millions of rands and millions of people sort of basically pulling in the right direction. What else was here? Yeah, platinum, palladium, the most important. Some of the downsides. Most of the PGE mines operate at a depth below 500 meters and 2.5 kilometers. Okay, a lot of electricity is used. Eskom, the swear word of South Africa. Okay. 90% of the electricity is generated through burning hard coal. The energy intensity of the PGE production process and the reliance of the industry on this energy source leads to a relatively high global warming potential per unit in PGE produced. There's a lot of innovation there, but ironically, the innovation in the platinum industry is getting back to basics. Just like you hear Rusty Erasmus saying, as long as we do the basics and do it without errors, you know the prize is worth it. And certainly the world is watching, not only the Springboks, but they're watching us as the stakeholders in the platinum industry. Is that we're waiting and we're watching. Hopefully we will not let them down. Thank you.